Article 700.12 of the National Electrical Code prohibits mixing equipment operating at different voltages within the same enclosure unless specifically designed and approved for such use. This means that having 480 volts, 120 volts, and 5 volts DC circuits all within the same panel could be a violation. Article 700.3b requires that each motor branch circuit be protected by an overcurrent protective device. Article 700.41b specifies that a motor branch circuit shall originate at the line side of the motor controller. Article 450.13 requires that transformers be installed in compliance with the applicable articles of the National Electrical Code. Article 450.22 prohibits the installation of a transformer in a panel board enclosure unless it is an integral part of a factory-assembled panel board. Article 725.112b requires that Class 2 and Class 3 remote control circuits be separated from other circuits by insulation, dielectric barriers, or enclosures. Based on this information, several violations of the National Electrical Code may exist. Firstly, the mixing of equipment operating at different voltages 480 volts, 120 volts, and 5 volts DC within the same enclosure or panel. Secondly, installing a transformer or dropping transformer within a panel board enclosure may be a violation. Thirdly, not originating the motor branch circuit at the line side of the motor controller or motor drive may be a violation. To comply with the National Electrical Code, the following corrective actions may be required. Firstly, separate the equipment operating at different voltages into different enclosures. This means that the 480 volt components, the 120 volt components, and the 5 volt DC components may need to be in separate enclosures to meet code requirements. Secondly, install the dropping transformer outside of the panel board enclosure in a suitable enclosure. The transformer should not be inside the panel unless it is an integral part of a factory-assembled panel board. Thirdly, reconnect the motor branch circuit to originate at the line side of the motor controller. This ensures proper protection and control of the motor circuit. Lastly, verify that the Class 2 and Class 3 remote control circuit, which is the 5 volts DC circuit, is properly separated from the other circuits by insulation, dielectric barriers, or enclosures as required by Article 725.112b. When dealing with electrical panels and different voltage systems, it is critical to understand and adhere to the National Electrical Code. Ignoring these regulations can lead to dangerous situations including equipment failure, fire hazards, and electrical shock. Always consult the most recent edition of the National Electrical Code and seek guidance from a qualified electrical inspector or engineer to ensure compliance. Improper installation can result in significant penalties and increased risk of harm to people and property. The National Electrical Code provides detailed guidelines for safe electrical installations, and understanding these guidelines is essential for anyone working with electrical systems. Firstly, regarding the mixing of voltages, the primary concern is the potential for insulation breakdown and accidental contact between different voltage levels. If a fault occurs, it can create a significant hazard and damage equipment. Secondly, the proper installation of transformers is critical for safety and efficiency. Transformers generate heat and require adequate ventilation. Enclosing them within a panel board without proper design considerations can lead to overheating and premature failure. Thirdly, the motor branch circuit must originate at the line side of the motor controller to ensure that the controller and the motor are properly protected by the overcurrent device. This configuration allows the overcurrent device to trip in the event of a fault in the motor or the controller, preventing further damage. Lastly, Class 2 and Class 3 remote control circuits operate at low voltages and have specific requirements for separation from higher voltage circuits to minimize the risk of electrical shock. These circuits are commonly used for control and signaling purposes and must be protected from interference and accidental contact with higher voltage conductors. In summary, it is essential to carefully review and understand the applicable articles of the National Electrical Code when working with electrical panels that contain multiple voltage systems, transformers, motor controllers, and remote control circuits. Following these guidelines will help ensure a safe and reliable electrical installation. Always prioritize safety and consult with qualified professionals when in doubt. Furthermore, consider the specific requirements of the equipment being installed. Motor drives, for example, often have specific installation instructions that must be followed to maintain the warranty and ensure proper operation. Pay attention to the grounding and bonding requirements as well, as these are critical for safety and proper operation of the electrical system. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent device to trip and clear the fault. Bonding ensures that all metal parts of the electrical system are at the same potential, reducing the risk of electrical shock. Be aware of the labeling requirements for electrical panels and equipment. Properly labeled panels make it easier to identify circuits and components, which can save time and reduce the risk of errors during maintenance and troubleshooting. Ensure that all labels are clear, legible, and durable. When making any changes to an electrical system, always document the changes thoroughly. This includes updating the panel schedules, wiring diagrams, and other relevant documentation. Accurate documentation is essential for future maintenance and troubleshooting. Also, consider the environmental conditions in which the electrical panel is installed. If the panel is located in a damp or corrosive environment, it may be necessary to use special enclosures and components that are designed to withstand these conditions. Regular inspections and maintenance are essential for ensuring the continued safety and reliability of an electrical system. Inspection should be performed by qualified personnel and should include a thorough examination of all components and wiring. Any deficiencies should be corrected promptly. In addition to the National Electrical Code, there may be local codes and regulations that apply to electrical installations. Be sure to check with the local authorities to determine what these requirements are and ensure that the installation complies with all applicable codes and regulations. Continuing education is essential for anyone working with electrical systems. The National Electrical Code is updated every 3 years, and it is important to stay current with the latest changes and requirements. Attend training courses and seminars to expand your knowledge and skills. Consider using arc flash protection. Arc flash is a dangerous electrical hazard that can cause serious injuries or death. Conduct an arc flash hazard analysis to determine the potential arc flash hazards in the electrical system and implement appropriate protective measures. Furthermore, use proper personal protective equipment when working on or near energized electrical equipment. This includes safety glasses, gloves, and flame-resistant clothing. Use insulated tools to reduce the risk of electrical shock. Never work on energized electrical equipment unless it is absolutely necessary. If possible, to energize the equipment before working on it. If it is necessary to work on energized equipment, use proper safe work practices and procedures. Implement a lockout-tagout program to ensure that equipment is properly energized before it is worked on. This program involves placing a lock and tag on the disconnect switch to prevent it from being accidentally turned on while someone is working on the equipment. Also, consider the use of ground fault circuit interrupters in areas where there is a risk of electrical shock. Ground fault circuit interrupters are designed to trip quickly when they detect a ground fault, which can prevent serious injuries or death. Ensure that all electrical equipment is properly grounded. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent device to trip and clear the fault. Inspect electrical cords and plugs regularly for damage. Replace any damaged cords or plugs immediately. Do not overload electrical circuits. Overloading a circuit can cause the wires to overheat, which can lead to a fire. Also, consider using surge protectors to protect sensitive electronic equipment from voltage surges. Voltage surges can damage or destroy electronic equipment. Never use extension cords as a permanent wiring solution. Extension cords are intended for temporary use only. Do not run extension cords under rugs or carpets. This can cause the cords to overheat and create a fire hazard. Keep electrical panels and equipment clean and free of debris. Dust and debris can cause equipment to overheat and fail. Be aware of the potential for static electricity. Static electricity can damage sensitive electronic equipment. Take precautions to minimize the buildup of static electricity. Also, consider using uninterruptible power supplies to protect sensitive electronic equipment from power outages. Uninterruptible power supplies provide backup power in the event of a power outage, which can prevent data loss and equipment damage. Ensure that all electrical work is performed by qualified personnel. Electrical work can be dangerous, and it should only be performed by someone who is properly trained and qualified. Obtain the necessary permits before starting any electrical work. Permits are required for many types of electrical work, and they help to ensure that the work is performed safely and in accordance with applicable codes and regulations. In conclusion, electrical safety is a critical concern, and it is essential to take the necessary precautions to protect yourself and others from electrical hazards. By following these guidelines, you can help to ensure a safe and reliable electrical system. Remember to always prioritize safety and consult with qualified professionals when in doubt.